And then we have question 5. Try not to be afraid if you see something like this. You should still be able to do it. Just read the question carefully. So, alright, for each of the following, write the two half equations, then add them together to get the overall redox equation. Make sure you leave out any spectator ions. Alright, so what it is happening here is they're giving you a situation. They're not giving you all the reactants and the products, but just the main species. So I guess what I'm going to start off with is I'm going to translate the text to just a scheme, like not the actual equation, but I just want to make sure I know what's going on. So first of all, we have acidify, which means that this is acidic. So if the condition is acidic, then I can use cohes. Probably should read the question again. What do I need? I need the two half equations and then the overall. All right, so it is potassium dichromate solution. So if I translate that, I will have K2 Cr2O7. I really hope I have enough room for this. And because it is a solution, it means that it is aqueous. You use it to oxidize ethanol. Ethanol is C2H5OH. However, I am going to use C2H6O just because it is easier to find oxidation number that way. The reason why I'm going with IQ is because you have a solution. So I guess when you mix the two, well, when you add ethanol to this solution, then effectively ethanol should exist in a solution as well. You have ethanoic acid being the product, which is CH3COOH. I'm going to collapse it into C2H4O2 simply to make it easier to find oxidation numbers. The dichromate ion is converted to chromium 3 ion, so that's Cr3 plus. So this is not an overall equation in any shape or form. I'm just trying to translate the words, especially the states, into some sort of symbols. All right, so -2, +1, this is +6, this is -2, +6, so we have -2, because essentially that has to be -4, and then -2, +4, sorry, that's +1, but the whole thing will be +4 though. +1 and 0, I should change these to +1, and then we have +3. So there is definitely a decrease in oxidation numbers of chromium from +6 to +3. So this undergoes reduction, which it is the oxidizing agent as the question indicates. It's used to oxidize ethanol. And there is an increase in oxidation number of carbon from -2 to 0. So it undergoes oxidation. The last thing is this is AQ and it is an ionic compound. So I could split it into 2K plus and Cr2O7 to minus, and because you don't actually see potassium ions being oxidized or reduced since it's not mentioned in the question, I think it's safe to assume that it is a spectator ion and you don't need to include it in your equations from now on, as the questions say that you should leave out any spectator ions. I don't think you can split anything else. Ethanol and ethanoic acid are both covalent. Ethanoic acid is not strong enough to be considered to be fully ionized. Okay, so my half equations with reduction, I'm going to go with Cr2O7 to minus, going to Cr3 plus, and I'm just going to use cohes again. So key element, I need 2 of this. I need 7H2O, 14H plus, and 6 electrons. You are going to write this particular half equation so many times this year that you will effectively memorize it. You never have to anyway. Alright, so for oxidation, we're going from C2H6O AQ to C2H4O2 AQ. Key element is already balanced. I have 1 oxygen on the product side, so I need an extra one. Now I have 8 hydrogen, so I need 4 more here, and I need 4 electrons. So that's AQ, and this is liquid. Alright, so that's my reduction and oxidation. If we do a quick oxidation number check, C going from -2 to 0 means you must lose 2 electrons, and since you have 2 carbon atoms, 4 electrons should be lost. I've done this one so many times. I know when I do. I know when I screw up? Actually, no. Let's just do a quick check too. 6 plus 2, 3 plus is 3 electrons being gained, and you have 2 electrons, sorry, 2 chromium atoms, so it should be 6 electrons overall. Okay, so for the overall, I do need to double the first half equation and triple the second one. So you should end up with 2 Cr2O7 2 minus AQ. There will be some cancelling, so I'm just going to write the species that definitely will not change first. C2H6O aqueous. We're going to 4 Cr3 plus and 3 C2H4O2 aqueous. Now, if we consider hydrogen, there should be 28 on the left and 12 on the right. So that will be 16 on the left at the end. For water, there's 14 on the left, sorry, 14 on the right and 3 on the left. So I should have 11 at the end. Just going to do a quick charge check. 16 plus 4. Okay, what am I doing? Yes, 16 and 4 is 12 plus, and then you have 12 plus here. Let's do oxygen, so this is 14. That's not meant to be there. 14 and 3 is 17, and we can get 6 and 11. So that looks good, I think. I'm happy with that for question 5a.